we can start the session. So hello everyone, hope you're all doing great today. So it's the day before the public holiday and before the celebration of Independence Day. So yeah, so let's then proceed today. Yeah, so today the plan is that we'll go through the more overview the activities 2 and 3. So we'll go through the solution and then we'll continue talking about object-oriented programming. Okay, yeah, so regarding your tests, I will take a look on them on Saturday. Yeah, so we'll have this large session, so most likely the idea would be that I will take the part of the session then, so I can check the assignments. Okay, so then let's proceed. Let's proceed. I will show also the results of activity 2 and 3 later this week. So then for now, let's then start with the solution. So maybe let's go one by one with where the tasks here, and then we can see the solution. Of course, that will be one of the solutions. That will be if we can write your own code, which can also be correct. That is always fine. There is no unique one unique solution which is correct here. So yeah, then regarding the instructions, I hope they all were clear for you. So then the first steps were the same as for the first activity. Just create the project and copy the files. Hope these steps are all clear for you. If you still have any technical issues, let me know. Then we can try to fix them, but I hope that you don't have. So yeah, then create solution, that was fine for everyone, then add existing files. So these points hope that were clear for everyone, and then starting the point 5, there is the codes to be written needed. So first of all, there is the constructor array base, and it initializes the array structure with the specified size of default array with default size. So there is this one. Yeah, we have two classes, array base and array stack. And so yeah, we have this have two constants, not in structure and default size. So default size means it's default size to be. So here and 10, yeah. So here we have the array, which is stored inside our class, then inside the object created from this class. And yeah, so here you can see, yeah, this is one more say feature we have in C# that we can place the default values for the attributes in the method. So it means that if the attribute is not provided, then the default value will be here. So yeah, then we need to initialize inside this constructor. We need to initialize the array, and yeah, so here was I was checking one solution from one of the participants, and the issue was that the sequence was not correct here. Yeah, so remember that we should firstly check so here basically the idea is that if the array size is less than 0, so if it's negative, then we need to use the default one. Yeah, so please see there was one solution, one of you provided that, and yeah, that was the issue that the array size was checked after the array was initialized. Yeah, so So this way that won't be correct, yeah, because then if the array size is negative, then this line of code will actually crash. It will trigger the exception because of course we cannot initialize the array with the negative size, so it should not exist. So here you have we have the array, so we are working with the object, so it means that we can define we can access the object members this way, or we can also use this keyword here, so that will be the same, and there are no differences. Here for the array size we cannot use this since it is the variable, yeah, it is the method parameter defined, so it is the local variable, it's not the let's say global variable or object variable. This belongs to, this is the variable, it belongs to this method, it is defined in this method, so it is not stored globally, yeah. So that's why here we cannot use this. Remember this syntax. For default size, yeah, that's the constant. So it can be, yeah, for constants, we usually use the naming that constants are all defined in uppercase. Yeah? So this is the usual approach. And since so just to distinguish constants and simple variables, yeah. So we usually use uppercase letters for the constants. This is just to see that they are constants inside the code. Yeah. And then we check if the size is less than 0, then we use default size. Otherwise, we can define the size of the array to be the same as provided. Okay, so for constructor, this is clear. Please don't forget about this sequence. Then we have public virtual integer method index of. So this the idea of this method, yeah, basically inside this these classes we define basically our own collections, yeah, our own collections for arrays and an array stack. So using these classes we can deal with the arrays as with the collections. So in this case it's needed for you just to understand how it is implemented and how does it work. Yeah, and then basically you'll see this method in most of the generic collections. There's this index of. Yeah, so here's the method. It is defined as virtual. It means that it can be overridden in the subclass. Yeah. So and basically, what does it mean? So you, again, as I said, you will most likely see it in most of the collections. It means that it is the method which searches for the corresponding object. Like, let's say that you have a collection of objects, then you ask this collection, please return me the position, the index of one particular object. Yeah, then it takes the object, it searches where is this object positioned at, and then returns the corresponding position to the corresponding index. Yeah, so this is the idea of this method. Yeah, so basically what does it do? It checks, so how it is usually implemented. It checks if the collection is not sorted, then it usually simply has full search. It means that we simply go through all the elements we have in the collection, in the array, then we compare them to the elements to find, and then we return index if it is found. Yeah, by the way, so I usually like to use the syntax without involving the brackets, just because I like it. For me, it looks smaller. Yeah, remember, if we have one statement only, then we can skip using brackets. So this is what I prefer to use, just to make the code smaller. Yeah, I like smaller code, and for me it looks pretty much clear since we have one statement only, one statement here, so I can skip using brackets here, and I have one statement here, so I can also skip using brackets here. But if you want, you can continue using brackets. This is fine, and some people think it's better to use them. Well, it depends. It depends. But so yeah, if we have one statement, then we can skip using them. Yeah, and by the way, the difference between equals and comparison, I would say we usually better use equals, but it depends. It depends, since again, yeah. So just at this point, that would be better if we understand the difference between equals and simple comparison. So let's then maybe create a new. I'll open a new window, and then I'll show you the example. So open the window, and I will yeah, I'll create a project. So that will be the project I will use today, and I'll add it to the existing demo solution I have. So that would be console application. Then I will add it under the practical tasks, but under the okay, I'll add it under practical tasks under demo then. So that would be demo today. And moment. Can't add it to the existing solution. Okay, one moment. Okay, yeah, I guess I need to then open the solution. And let me then open the solution. Okay, it will close me the existing window or not. Let me check. Let's see. Yeah, actually, Visual Studio is more heavy than Visual Studio Code from the memory consumption point of view. That's why it may be difficult to open multiple windows. Okay, then I guess my computer is not crashing, so it's already good. Okay, so it's fine. I'm opening it. Okay, so let me then create the solution for today, the project for today. Okay. For each loop, one moment. The question from Owen: is it possible to write this method using for each loop? Yeah, actually, it is possible. Yeah, we can. Oh no, hold on. It is possible, but then yeah, we can always do it. Why not? But yeah, then we would need to define the index separately. Index equals -1. No, hold on. Index -1. then we can write for each. Yeah, for each, then that will be, so we store t, the elements, then in store array. And yeah, so then we would need to increment index here, and then we need to check if the element equals to the argument we need to search for. Then we return the current index. And we return the current index. But yeah, that would be larger in this case. I think it. Yeah, I think we cannot use any system variables if I'm not mistaken. Because in some programming languages there are the system variables, which then can be used. Okay, so if you want to use for each, then you can use this approach. But yeah, for loop, for this particular case, would be preferable, since we need to have the index. I can't declare new variables. No, it was said I can't declare new variables in the class. Not under the methods. Was it? I think that was somewhere here. Yeah, I remember, but a constant, blah, blah, blah. I think it was written somewhere, but if I'm not mistaken, that was meant to not declare the I think that was about the declaration inside the class. Yeah. About the global variables inside the class. Yes, I think. Let me check. Where was it defined? Where was it? Okay, not here. But yeah, if I'm not mistaken, that was about the class variables. Yeah, the object variables, the global variables inside the class. Yeah, question from Wien. So the answer is simple. We need to find the index. We need to find the position where the element is located. So that's why we need to use. But yeah, that was actually the question from Owen. Can we use for each here? We need to know the index. That's why we need to define it. But I mean, the easier approach would be if we use for int. Yeah. Yeah. Yeah, also a good question. No, there should be no difference. There should be no difference. Yeah, that's also a good point. That's also a good point. Yeah, so you can also write it this way. Hold on. Arc define, yeah. Find then that should be store array I. Yeah, so that one there should not be difference. So, since you compare, yeah, but actually from the from the mathematical point of view, it's really a good question, because yeah, mathematics in math, it's not always correct, and the comparison, if you compare the left side to the right side, like it's not true in all the possible cases when you compare objects, and in math. Yeah, so that's why. Yeah, that's this is relevant question. This is relevant question. And in fact, you can create such logic even for your objects. Even for your objects. Well, let's maybe do it. Yeah, because this is, I would say, quite interesting question. Quite interesting question. If it is, I mean, in normal case, in usual case, that should be correct, but maybe in some special case. Well, I guess I just created it, wasn't it? Two. Yeah, that's quite an interesting question because it can, there may be, I mean, there may be some exceptions if you define such, but I would say there would be quite special, but in theory, why not? Theory, why not? So, for example, let's say that I have my, so I define my class, that would be my object. Yeah, so what would be my object? And as we discussed last time, we need to implement interface comparable. Comparable to then one moment, yeah, then one moment. I guess for standard object there was no such methods, if I'm not mistaken. One moment. Let's quickly check. Yeah, that's for what? So let's quickly then check. Yeah, I guess for. Oh no, okay, that one. It was. Okay, this is the standard method. Okay, then I guess we don't need comparison there. Or yeah, I think we don't need to. Yeah, because comparable means that we compare what is greater than another. Okay, yeah, then this would be. Then I think we can overwrite equals. Yeah, we can overwrite equals. That then we can actually compare it to. So I think we can specify that I want to compare it to my object. Oh, hold on. Okay, then maybe let's compare it with the current object. And basically, what can I do here? I can basically define your own logic, yeah, and this logic can simply, okay, maybe this would be quite strange, but yeah, basically we can write everything we want here. Yeah, so. Oh, hold on one moment. One moment. So. I mean direct. Yeah, I mean direct to them, but I mean. Yeah. I mean, in programming, you can. I mean, the idea is that here I can define whatever I want. So I can write the logic, which will maybe result in in differences between what we compare. Yeah. I mean, I override it, and it is. I mean, in standard case, there is no actually standard case if you work with the classes, because I mean, because normally for default case, there is no definition what is the comparison for the objects, like how you can compare, let's say, so you yes, yeah. Yeah, but I mean, in this case, we work with the array which can have any type. Yeah, so we have type T. So it means that we can place any object we want here. Yeah, so it means that for yeah, it can be different. So it means that we can also define our own object, which will have some crazy logic inside. And maybe I will not provide the example here because I mean I cannot right now imagine the crazy example, but there can be some crazy examples which may some yeah, maybe sometime if I yes, we can also think about such crazy examples when A equals B and B not equals A. And I mean, mathematically, I won't agree that it is always correct, since I mean, mathematically, there can be some strange, not strange, but some interesting structures which which may result in the situation when A equals B and B not equals A. Maybe I cannot really imagine such situations now, but some complicated structures there can be. For example, I guess you know that for the matrices, if we multiply matrices, then if we multiply A by B, it will not be the same. It will not always be the same if we multiply B by yeah, for matrices. And for comparisons, there may be such cases as well, I would say. But I would maybe at this point, this one maybe this will this will um, this needs to then we need to go deeper here, and this will be maybe more math. Sorry. In this particular example, this should normally be the same, but I mean it depends on the object we place. Again, it depends on the object we place. If we place the object if we place the objects uh, which are quite crazy, which are defined crazy, then there's maybe yeah, there may be crazy examples. Yeah, I mean we can define some dummy example. For example, if we say if I have private string, let's say my string, then let's say I define the constructor of the object. So we can define more clever example, but maybe I will just define dummy example here. So that means my string equals my string, and then I redefine method equals public override equals, and then maybe I return something like just what can I define? I say if I return this private. Okay, maybe let's define public just to make it shorter now. Again, normally we need to define it as private and getter status, but in this particular case, just for you to, for instance, let's say that would be say something like AA or just any text. Yeah, any text we can write, and then objects my string. Where is this? Hold on. Yeah, let me maybe cast. I think, yeah, we can cast it. My object. So my object, then I will cast my object here, and then I will assign the value. If my string equals bb, then we return true, else we return false. Yeah, and maybe such interesting cases. So what does it mean? It means that let's create two objects. Let's say object A. Then I create an object. Then I define it with the string A. Then let's say I define another object and let's define it with string bb. And then let's see the results. So I say object A equals object B. And then let's define the opposite. Let's write the opposite direction. Yeah. Okay, so let's run and see the result. Why wants to run test? Don't want to run test. No, what's going on? Oh, okay. Let's run from here. Oh, hold on, they both are false. One are false. It's yeah, of course, BBB, typo B. Sorry, sorry, typo. No typo. So just I missed one B. Sorry, my mistake. Let's run again. Yeah, you see now the results are different. Yeah, but I mean it depends on how we define this equals method, because again also mathematically how do we compare two objects? Also from a mathematical point of view, it can be not just simply that we compare the values or something like this, because again also in mathematics we may have complex objects like matrices, or maybe some more complicated structures, matrices again some. Basically, there can be also, same as in programming, we may have complex objects in mathematics like vectors or like lots of different things we can have. Yeah, and so how do we compare them? It depends how the comparison operation is defined. Yeah, because also the same as in programming, we can redefine it and write our own logic. Also in mathematics, it can be different. Yeah. So just for you to understand that that's not always mandatory, but in usual case, they are the same. So just for your information. But yeah, that's a good question. That's a good question. Also from the theory point of view, it's quite interesting question, I would say. But yeah, so in our case, let's say that they are the results are the same. Okay, then we find, and if search is unsuccessful, then we return not in structure. minus 1. This is constant, yeah, so you can see the example how we can use the constants. Yeah, so of course we can always use minus 1, but this won't be safe because, I mean, also from the testing point of view. So let's go here, and I guess yeah, you can see the constant is also used here. So it means that, of course, I can use minus 1, but that won't be safe, yeah, because if I change Norton structure value here, then I also need to change it here. Yeah, so if for some reasons I want to change it. And so that's why constants are preferable, just because it's safe to use them. Yeah, if I change the value in one place, then the value will automatically be changed in another place. And so again, if I change the value here for this constant, then it will also be changed in all the places where this constant is used, right? So that's why this is a good example how we use constants. Okay, so that was the first method to implement. Then let's move. So is this method clear for you? Are there any questions why this particular logic is written here? So again, let's go back. Index of. Yeah, I can press Control, then type on the method name, then you're gonna navigate there. So hope this method is then clear. Okay, then let's go next. Next one will be the method add, which adds new object to the array and returns not in structure if array is null or is full, or added element index if addition succeeded. Yeah, so yeah, this is this method, and so I can first check if it is full. So I can call the method this is full. So is full can check if the number of the elements reached capacity. This method has, this array has. Then yeah. So if it's full, then needs to yeah, we can trigger the. Yeah, I guess there was no task here. Yeah, so that we need to trigger the exception. Okay, I guess this exception was not needed. Sorry. So that was just, yeah, I guess that was not needed. So yeah, then we check if the current count exceeds the capacity. Then we return not in structure. Otherwise, we add the element to the array and we increment. Yeah, so current count starts at 0, and yeah. So remember that here you should, if you use this approach, then you should use post increment. Yeah. So in this case, that won't be correct. If you type it this way, if you type it this way, then it won't be correct. In this particular case, why? Because we start at 0, and then it means that it will firstly do the incrementation. Yes, so it will first increment current count, and then it will apply it to the indexation of the array. So this case means that it will first we add 1, and then it will access this element of the array. Yeah. So, but if we do it this way, then it means that it will firstly access the element of the array, so that will be current count. And after that, after it is accessed, then it will be incremented by 1. So, in this case, be careful because the operation, because of the sequence of the operation here. Okay, so is it clear for you? Okay, so if it's clear, then let's move on. The next one will be remove at. Means it checks for the index, and then yeah, remove item from the array. But if array is empty, then we need to throw invalid operation exception. So then we can check if array is empty, and then trigger the exception. Otherwise, check so if the index is negative or it exceeds the capacity, then we can throw invalid operation exception. I guess, but also I guess that was not requested. Array at the position throws. Oh, actually remove, then it's not possible. Okay, and then we'll also check to capacity. Otherwise we need to compact the elements, so it means that we need to shift the elements. So we need to shift the elements, then we use this particular shifting. That means that if we remove the element at one exact position, then we need to shift the elements left from right. Yeah, so this is what I do now. I have -1 here because we then use the last element. So if we use the last element, then this would be the last from right. And here you see I use prefix increment. This is because I first need to increment I, and then I add 1. But one moment, I guess. Yes, that will be correct. One moment, sorry. Yeah, I better use the I+1. Yeah, I do not increment it then, because that won't be safe here. Okay, so and now it is done. Yeah, so now it is done. And then the next one would be that we check array stack. Okay, we go to array stack. So then we don't have logic in the constructors. So this means we'll talk about it later today about the inheritance, but this means that the constructor from the superclass is called. Yeah. So then we have the point to push the element. So remember what the stack structure is. So the stack means that the best representation of the stack is the call stack we have in programming. Yeah. So when we call the method, how basically the program works, we start at one method, right? Like usually it's the starter method. So we start from this particular method, then we go deeper. It means that we have, maybe let's try to paint it just so everyone can understand this structure. You can see that I use to be shape. And so we are at our base starter method. So we start. We have the logic here. Then this method, let's say it calls another method. So let's say it calls another method. Then another method then is called. Then this method calls another method. So then there is again another method called, and so on and so on. Yeah? So at this point we have this representation of the stack. Yeah, one method calls another, then new element is added, and so on. Yeah. Then, so method is called, then another method calls another method, and so we go deeper, deeper, and deeper. So once the execution of the method is finished, then what happens? Then the element from the stack is removed, then, and there is one element once. And this is what happens. Yeah, so we push the element to the stack, means that we add a new element. Otherwise, we pop the element, means that we remove the element from the stack. Then, so then we need to implement these methods. So first of all, it's push. Then it means that I add a new element. So what does it do? So implement this method so it pushes the item element onto the top of the stack, assuming that the stack is not full. Yeah. So we have also here we have the limitation to the stack, so it means that the number of the elements is limited. Yeah, and at the bottom is 0, and then we check. Yeah, we check if it's the value type. I guess that was requested that it should be the value type. Or not. Oh yeah, so remember that it has the structure last in first out. That means that the last element added to the stack, it will be the first one to go out from the stack. Okay, yeah. So it was requested here, .NET Core use type of T step to check if this is the value type. Yeah, so here we can, so basically here we can check if this is the value type. And it's not the reference type, just to check it out. And yeah, then again we check if capacity is not exceeded. And then we can use this approach, or we can use the same as before. We can increment count here, so there's no difference. Okay, so this is for push, and then for pop means that we simply remove the last element. We can do it this way, or we can also just do it then this way. So if you want, you can also assign new element. Oh, no, we can't, because yeah, okay, it's not null, but then let's then do this. Okay. Okay, so okay, then we also have p method, which then returns the last element. Okay? Which then returns the last element. Yeah. So, and then let's run the tests. Let's run the test. Okay, I know the tests are passed. Do you have any questions? Okay, then I can give you one small hint how to better proceed with these tasks, and just to check if something is wrong with the unit test. Yeah, so usually when the unit test fails, it shows the stack trace. It shows the stack trace, which particular line of test is is failed. Yeah, so for example, I can show that this one failed, or no, sorry, this one failed, or this one failed. And you'll see it in the stack trace. Then you can, what you can do, you can navigate to this one, and you can point you can add the breakpoint, insert breakpoint. So you can insert breakpoint. So if you see that the one fails, then you can debug tests. You can debug tests. So when you're debugging the test, then the breakpoint needs to be triggered. Okay, let's wait until breakpoint is reached. Okay, so we are now here, and then we can. Where are we? It was. Yeah, okay, it shows all the exceptions. It will trigger all the exceptions we have. Yeah, now we are here. So then I can go deeper if I want. Maybe that was not the best example. Let's step over here, and then we can, yeah, so if it's true, then we can go deeper, step in. Okay, then it will trigger the method is full. Then you can see what is here. Yeah, so you can check the values you have this moment of code, yeah, and see if something goes wrong. So, okay, now the question to you: are you familiar with the debugging? So during my previous course, we had a little bit, but the question to you is: how good are you familiar with the debugging? So, are you able to debug the code? Okay, that's good. Then I hope that you can try, and so it's the best learning for debugging. Best learning of debugging is if you try it yourself, because there is no really much to show. You need to put, yeah, first you need to put the breakpoint. Don't forget about it. And once you place the breakpoints, and if the program stops at this particular point, then maybe. So that was not the best example. Let's say that, maybe let's try this particular case. So I point to breakpoint. So breakpoint, and so you need to run then your program in debug mode. So for tests, that will be debug tests. Then it will stop at all the exceptions, at each exception triggered. Like if exception is raised, then it will stop there. If it throws an exception, then you can, yeah. So for debugging, remember that you have steps. So you can have a small step. So the small step would be step into. So it means that it will simply go to the next executable line of the code. If you have step over, then it will not go. Like if you have the method call somewhere in the code, yeah, maybe. Yeah, if you have the method call somewhere in the code, then it will go inside this method. If you use step over, then it will execute the method, but it will not go inside with you. I mean, you will not see what happens inside the method. You will just simply go to the next statement you have in the current stack level. Step out means the program will execute all the steps in the current method, and it will jump out of the method here and jump to the previous stack. You will not see, you'll skip seeing what happens in the further statements of the current methods, it will just simply kick you out, not kick you out, but you'll go out of the method. And then then the next one is continue, means you'll go to the next breakpoint, or also you see that exceptions, it also stops at the exceptions. So first continue means I go to the next breakpoint. And yeah, so now I'm here, I can go, so if I want I can step over, means that I'll go to the next one in the same stack, to the next executable. Then if I press step into, I go inside this add method. Yeah, by the way, you can place to the object, then you can place your cursor on the object, and then you can see how the object looks like. So here I can see the values the object has. Yeah, I guess I can also, can I change? Oh no, so I can't change the value, unfortunately. Oh no, I can for, okay, I can even change the value if I want. So it's also possible. And then step into, I can okay, yeah, so now I'm stepping into, and here I can go through all the executable points, and if I press step out, it means that I will not see what happens next. Here I will go back to the previous method. And so this is step out. So just in case you want to see what's going wrong with the unit tests, you can use the debugger then. That would be the hint how to check. Okay, so do you have any questions about this task? Yeah, yeah. Yeah. Uh, which names? Sorry, which names? Yeah. Yeah. So these are. Yeah. 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 Because I create the structure of the class, which then can be used for other objects. So you can see that they are used under the test. Yeah? So this is the idea. I create the library. So we create the library here. Then this is the library which stores the classes, the structures, the templates of the objects. Then inside the test methods, inside the test classes, then you can see that the array stack is created here, and then array stack actually uses these methods here. And so these methods are, yeah, yeah. I, I, yes, yeah, yeah, yeah. Mm, I mean, No, I mean this particular action. So this is the object-oriented programming. I have the method which defines the behavior on this particular object we have. So the object would be the stack. So this is the object, and then I say, please pop the element from. Okay, so this is not needed. Yeah. No, I mean it. I mean the elements are stored in the array. Yeah, so you see that the elements are stored in the array. We have this array defined. I mean the array is defined. So basically everything what happens there is based on the array we have. Yeah, so it simply works with the array. So it means that when we pop, it means that we actually pop from the array. And so we. No, I mean the name of method is used so in the place where this particular class is used. So in our case, it is used in activity test. So it calls this method, yeah, push pop or whatever it is. Then this method is called. The logic is called from there, and then it simply does the corresponding operation on the array. Yeah, so we yeah, in this case, when we have the method pop, it returns the element. Yeah, it returns the last element then. Yes. I mean, if you use the generic classes, then they will be there. Yeah, yeah. I mean, this is your own implementation. Yeah, so this is different. You this yeah. I mean, if you can, I would say for yeah, for stack methods, the standard definitions of stack methods. Sorry, stack structures, stack objects. Yes, then you'll see these methods, of course. Yeah. Yes. Yeah. Yes. Yeah. That's correct. But yeah, that's just for you to understand how these how these structures are normally implemented and stored. Yeah. 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 I mean, for yourself, that would be fine. But I mean, I will. I guess I'm sharing this code with you, so you have the access to it. Uh, I mean for homework in general, since yeah, you are learning, and so just for you, the key point here is that you at least you try, and that's all. That's so it's not about the marks. Just you can you can learn it. Okay. So do you have any more questions? Okay. Then if there are no questions, I guess we can have then 10 minutes break, and then we will continue with the next activity. So let's then meet at 7:46, I guess. Yeah. me open the solution for activity. Meanwhile. Okay, so then open the task. Okay. So yeah, then let's continue. Let's continue with activity 3 then. So what was requested here? So the first steps were the same, yeah, enter array base, array queue, yeah, and then we had to implement it. So here we're talking about queue. So what's the difference between stack and queue? So from the real life, stack has the structure first in, last out. So and queue has the structure first in, first out. Yeah, so just a simple queue you have everywhere. Yeah, everywhere where you have the queues, then usually the first one in the queue is the one who gets what he she wants first. So then this needs to be implemented again. Also, we have the queue structure, the generic queue structure defined, so we can use it. But in this particular case, the idea was that you implement this queue yourself. So yeah, then let's start and yeah. First of all, we need to and queue needs that it means that it places an object at the end of the queue. So if the queue is, I need to check if the queue is not full, and so there is the check if the object is not already in the queue, so it means that we have the check on the duplicates. Yeah? So we do not allow duplicate entries to be enters to the queue. Yeah? So, and then it returns true or false. So let's check. Yeah. So first we check if the elements we add to the queue is not null. And then we check if the current queue contains the element. So if it contains or the queue is, then we return false. So I mean the same as we had in stack structure. And then we actually add the element. So we increment last and then we assign next again. That would be the same if we do it this way. Oh no, hold on, this way. Or yeah, actually here I start the last is -1. So maybe let's maybe keep it as it before. But yeah, so in this case we can do it this way. So it depends where you start. Yeah, if you start at 0, then then it needs to be post increment. If you start at -1, then it needs to be pre-increment. And then I return true if everything is correct. So this is for NQ. Then we go to TQ. TQ, it means that we remove the element from Q. And so then we check if the queue is empty. then we throw the exception. So then, what is this? Oh, it's fine. Yeah. Then I start with the first one. Start with the first one. So I mean, not I start, but I take the first one. So that would be returned then. So what we need to return, and then I shift the elements. So I can shift the elements the same way as we did it before. I shift the elements, and then I return the first element. Okay. So is this point clear? Okay. So then, then we move next. Then we move next, index off. So this is the same as we had it in the previous activity. So the idea is simply the same. So we check the elements and we return. Yeah. So here we have this first. Actually, in my solution, I did not use first. So for my case, that would always be 0. So it means that this would just simply be the same as I. And so don't pay attention that I have this first here, because I mean for my particular solution it will always be 0. And that's why it will not affect the result here. But I mean, it depends on how you implement this solution. So yeah, but the idea is the same as in the previous task. And the last one is check. Instead, it checks if the object is at specified index related to the start of the queue. So yeah, then simply checks an object in the current of the specified index related to the start of the queue. Okay, so and then let's run the tests. Where are my tests? Okay, let's try again. I'm sure my tests are missing. Yeah, so you can check if maybe at some points the build maybe failed, then you cannot run your program. But this particular case, hold on, yes. So it does not pop. It does not pop up. It simply shows it in the separate screen. Yeah. So all the tests are good here. Do you have any questions about this array queue structure? Okay, then if not, we can then finish with these activities, and then on Saturday, then I will share I guess new activities with you. Okay, then let's move back to the presentations. So remember last time we started talking about the inheritance. Yeah? So remember we had the key concept of inheritance is so-called top-down design, and we say that all the classes defined in the below the class, then we also say that the classes defined below, they have is a relationship to the class which is above in this hierarchy. So again, it always means that here we have this top-down design. It always means that here we say that bulldog is dog and dog is animal. And this is a relationship, and it is not correct in opposite direction. Again, what I said here, because animal is not a dog and dog is not a bulldog. So bulldog is dog is animal, but animal is not a dog and dog is not a bulldog. Yeah. So same as here, dog is animal, cat is animal, cow is animal, but animal is not cow, animal is not cat, and animal is not dog. So this is a top-down design. And also same as here. Yeah, this is what we have. Remember this. Sometimes we may have the composition of the objects, and then we has a relationship. It simply means that one object contains another object inside itself. Yeah, so car has engine, car has wheel, but engine does not have a car, and wheel does not have a car as well. And also engine does not have a wheel, and the wheel does not have engine. Yeah? So the relationship only works from the top level, from the object level to the component level. Yeah. So this is about the relationships. Yeah. Also, what I mentioned last time, there is such in programming, there is such thing called multiple inheritance. Yeah, it means that one class can inherit from multiple classes, but it's not allowed in C#. It is allowed in C++, and I think similar languages. To be honest, I have not experienced any language but C++, which has multiple inheritance, and it's simply because in C# we do have interfaces, but in C++ there are no interfaces yet. That this is the reason. And yeah, back to the question, maybe why multiple inheritance is not so popular in programming. Why it does not exist in C# or similar languages, and the answer is quite simple. Because imagine the situation when this is related to the method overriding. So we'll talk about overriding a bit later. But the thing is, and I guess you already experienced this, that we have the method. Let's say we have virtual method, and then we have the subclass. Then this method is inherited. Yeah, it's public and protected. Then this method is inherited, and we can then use this method from the subclass. Yeah. So, but then let's imagine the situation when we have multiple inheritance, and let's say that the class horse has the method virtual method public or protected method right, for example. Okay. So, and then let's say also donkey has the method right, with the same structure. So then just imagine the situation when these two classes are, no class is inherited from horse and donkey. Then the question may be which method then this subclass needs to use. Should it use the method from horse class, or should it use the method from donkey class? Yeah. So this is the problem. This is the problem for multiple inheritance, because because in such situations, we have the conflict, because then the class tries to inherit same methods from two different classes, and as I said, the issue is which methods needs to be used then. That's why multiple inheritance is not used in is not supported by C# or also similar other similar languages. In C# we can only inherit from one class. So we can have only one superclass, but we can have the interfaces. This may solve the situation of for multiple inheritance. Okay, so if you have any questions, let me know. Then so how to implement the inheritance? So we use column, and then after the column we specify what class we want to inherit from, what we want to extend. And if we extend the superclass, like in this case, we have the class person, which is now our base class, our superclass for the class test person, and we see that it has two elements, two attributes, age and name. And then what does it mean? It means that these two methods are then inherited by the class. And these two attributes are then inherited by class person, test person, and it means that we can use them inside as a part of test person class. So it means that test person class will take these attributes as well, and they can be used same way as they are used for from the person class. So they are inherited. They are then used. So we can see that we can create test person class, and then we can access these attributes. And of course, in addition, we can access the attributes from the test person class itself. So that's the point. That's the point, and this is the key point, and also for you to understand how to and when to use the inheritance. How to use the inheritance, because remember that the key point for the inheritance is that we extend the class, the superclass with additional attributes. So it simply means that it still stays as the superclass is, plus in addition it has more properties, more parameters, let's say more features. So this is important to understand, that the subclass has all the parameters that all the features that the superclass has. So this is important point to understand. So when you use it, please don't forget it. Don't use your own concepts, because this is how it normally should be. Like if you have the super, and also I'm not sure if I told you before, but also for the frameworks. For the frameworks, you may use. There's a situation that the frameworks, let's say they have the classes. They have some classes. Again, any framework you use. Most of the frameworks you use, when you have the object-oriented programming used, then what the frameworks do have. So sometimes, like you may, for example, let's say that you want to build your project. Maybe that would be the website. So how you can normally proceed? You can use the frameworks. You can use the frameworks, and then what the frameworks usually have. What the frameworks usually have and how the frameworks usually work. So there are the templates. There may be the templates created and the templates have some kind of what we call it generic solution. Yeah, so it means that something what is what is created by default. Yeah, created by default, some kind of template. And then let's say that you want to implement something new there. Yeah, so you want to make some additions, you want to create your own solution. So what does it normally mean? It does not mean that you simply destroy everything, or at least small part of what is created, what is defined in the framework. But what you actually do is that you extend what is defined in this template, in this default solution. Yeah, so in this case, it means that you usually how it works, you define your own your own classes, and you extend the generic classes. Yeah, the classes from the framework. Then actually your classes may be used as the main as the part of the main solution. So this is the point, and this is, I would say, maybe from the programming point of view and from programming usage point of view, is the key way, at least from my experience, this is the key point of object-oriented programming, the key usage of object-oriented programming, that there is some kind of generic framework, yeah, generic solution, and then you extend this generic solution, which usually means that you extend the generic classes, generic code with your own code. Yeah, and this is basically the way how we usually work. Yeah, and it's not only in .NET, I would say, from my experience, in most of the programming languages and frameworks I was working with, you have, say, you may even download some code from GitHub also for some reasons, for some purpose, and then extend this. Then basically it. So what's the advantages? Advantage is that you have the code what you reuse. Yeah, you extend the code which already exists. This is the first point. So it means that you add something new. Then it means that, and basically what happens. Okay, so you'll see. We'll talk about the casting, about polymorphism. Yeah, that would be the next topic, and so maybe this will be more around there. But yeah, then the thing is that you use some kind of base, some kind of solution, then you extend it with your own code. And another advantage here would be related to the updates, because normally when we work with any solution, yeah, on practice, when we work with any solution, any possible solution, then we normally have the updates, the upgrades for the frameworks, for the systems where applications we're working with. And yeah, then let's say that you have written your logic, and this logic is based on any framework. And then let's say someday, and this framework, then there is the upgrade for this framework, and then you need to install this upgrade, this update for a particular framework. Like, it can be any framework. It's not meant that it's .NET. It can be any framework. And yeah, then basically what will happen with your code then? So if you implemented everything correctly, if you use the subclasses, so it means that your classes will not be touched. Only the superclasses will be touched. And then if the superclasses are touched, they should, I mean, if the framework does not do any radical, any serious changes on the structural changes, then your subclasses should normally not be touched. Then, yeah, so it means that your subclasses will not be affected. And this is the point. Yeah, this is the point of the inheritance. And I would say, in general, from the usage point of view of object-oriented programming. Yeah, we extend the existing solution then. Okay, so then also for the inheritance there are two important things there. This and base. Remember that we already use this, and this simply points to the current object, to the current way in. But there is also such keyword base, and I won't really say that this base is something similar to this. But the thing is that base points to the elements which are defined in the superclass, in the parent class. So it means that we can use base to then, let's say, call the implementation of the methods defined in the superclass. Yeah. Or like in this case, we can access the attributes which are defined in the superclass using getters and setters. So it means we call using base class, we can access the public getter of the methods of the attribute age. Yeah, but in this particular case, I think there should not be. Copy paste this code. Let's try. There should not be any difference if I use base or this. Let's see. Let's see. I need to then also define the superclass. This person. Okay. Yeah, and so if I use this, I think I can also use this then. So actually there is no difference if I access the methods which are not overridden, then there should not be difference between if I use this or base. Yeah, so for you this may be a little bit confusing, but base is mostly needed for the methods. Like simply you can see here we have getters and setters. They are getter and setter. They are also the methods. And so yeah, base simply means that we access the methods, the implementation of the methods defined in the superclass. So this is mostly related to the methods overriding. So then I will talk about it more when we reach the topic about methods overriding and overloading. So yeah, but yeah, so if you want, you can use base to access the elements defined in the parent class. But there won't be difference. The difference will be if we override these methods. Then there is the difference if we use base or not. Okay. So do you have any questions? Okay. And I hope it's all clear. We can proceed next. Yeah. Yeah. So this is what I said. When we override the methods, then we can use base class to access the base keyword to access the implementation defined in the parent class. So what's the point? When we have the methods in the classes, we can, if we use the inheritance, then it means that we can override the virtual methods in the subclasses. And so it means that we can define the different implementation of the methods in the subclass. And what's the point? The point here is that here I have this implementation in the subclass and I have this implementation in the superclass. So basically, if I want to access the implementation from the defined in the superclass, then I can simply use base and then I can call the method. Yeah, so this will call the implementation that is defined in the superclass. So this is the point here. Okay, so do you have any questions about it? Yeah, so use base. Oh, yeah, question. One moment. So what you said, system console, and what was the first one you said? I mean, you can't. Yeah. I mean, if you don't have this using system console, then this should be the issue then. Yeah. So if you define it, if you use it, I mean, if you define using system console, then it means that this will already be included inside your code. So it means that you don't need to write the system console. It means that it will already use this console inside, and it means that we can skip using these. Yeah. You mean system? Yeah, I mean this is also up to you. If I write the full definition, then if I don't use this system, then I also need to write this system console. If I use system, then it means that I can skip using system in the code. And if I use system console, then I can even skip writing system console as well. So this is based on what you are using here on the top. Yeah, if you're using nothing, then you always need to write system and all the further variables there. So, but actually, from the usage point of view, there's no difference. Yeah, especially for system, because sometimes the point may be that these prefixes may the prefixes or the names of the classes, they may match each other. Yeah, so it means that there may be class A, which is taken from one library, and then there may be class A, which is taken from another library. And then there may be confusion which particular class is actually used. And that's why in such cases, when we have such duplicates, such matches in between the names of the classes, then we need to write the full text to then distinguish them. Yeah. So just simply say that we have class A defined in the library A, and then we have class A defined in the library. Oh, it would be better. Class A defined in library 1, and then class A defined in library 2. Then to distinguish them, we need to write the full namespace library 1 dot class. So then we can access one class, or then to access another class, we need to write library 2, and then that will be class 1 there, class A. So just then need to write the full name there. Okay. So if it's clear, we can move on. And now, then the next point would be the constructors. So what's the point for the constructors? Remember I said that when we extending the superclass, means that we have this is a relationship. So again, means that all the objects of the Subclasses, they are also the objects of the superclasses. Yeah, and simply what does it mean? It means that when I create the object of the subclass, it means that it should trigger all the creation processes from the superclass as well. So at the end, it means that I need to trigger these processes, and I mean the key process is the constructor, right? So it means that when I create the object, the constructor is called, and if I have the superclass defined, of the class defined, then I firstly need to construct the superclass, the object of the superclass, and then I can extend it with the construction of the object from the subclass. And this is what is mandatory for the objects, for the constructors. So the idea is when we creating the constructor, or when we are creating the object of any subclass, as I just said, then it also firstly it needs to construct the object of the superclass. Yep, and that's why basically what happens, the constructor, base constructor, we need to call base constructor. Yeah, we always need to call the constructor of the superclass when we create the object of the subclass. This is mandatory. This is mandatory, and if and yeah, again, remember we have the situation when we have parameterized and non-parameterized constructors. So yeah, basically what happens when we have non-parameterized constructor, it means that it can, like we have non-parameterized constructor in the superclass, then it triggers this non-parameterized constructor automatically. Yeah? But on the other hand, if all the constructors are parameterized, like here, we don't have the constructor without the parameters, and uh, that's why we need to pass the values for these parameters some way, right? Because when I try to create the object of the subclass, in this case that's the student, then again you see it has parameterized constructor, but again I also need to construct and the object of the superclass, yeah, the object of the person. So, and what I see here, I see that there is the constructor which requires the name. Yeah, I cannot construct the person, I cannot create the object of the person without the name. That's why, and yeah, the thing is then when this constructor is called, it needs to pass these values, the corresponding value to the constructor of the superclass, because it cannot be done automatically without the code, because the program simply does not understand how to pass these parameters. Yeah, this is why we must call this we must call the constructor of the superclass this way, that we use base. That means we call the constructor of the superclass and we provide the parameter. And so the parameter is then passed to the constructor of the superclass, and then the constructor of the superclass is triggered. Yeah, and then after a constructor of the superclass is triggered, then the constructor of the subclass is triggered as well. Yeah. So this is the point. Do you have a question about it? So, and this is mandatory. This is mandatory if constructor is parameterized, then it needs to be called from the subclass. Okay, then maybe at this point I need to have a short break. So let's say let's take 5 minutes break. Let's meet now for 5 minutes, and then I'll be back in 5 minutes. Okay. Okay, so I'm back. Let's continue then. Okay. So. Yeah, in case you have any questions, let me know that. Yeah. Then there's second thing. Second thing is the keyword this using in the constructors. So what does it mean? It means that you can call one constructor from another. So basically, again, usually what we have the constructors with different patterns for the parameters. Yeah, so if we have parameterized constructors, then they may have different parameters there and different number of the parameters. So usually it means that there may be some default values for the elements for the members of the objects, and then we can provide not additional, but change the values to these parameters from the constructors. And that's why we may have some different constructors with different number of the elements there. And this what means that we can have the parameter where we have, for example, in this case, we have only name. Then we can call the parameter which has name. Also, it has name and it has age, but I can then provide default value for an age. And then this particular parameter would be then this particular constructor will be called, yeah, and then the age 0 will be set there. Also, for example, we can have the constructor which takes age as the input, as the parameter, and then we can assign, in this case, we can assign default value for the name then. So basically, yeah, we call one constructor from another this way. Do you have any questions about this? Okay, then I hope it's clear for the inheritance. Do you have any questions for the inheritance in general? No. It's not the reference. It's just the way how you can access the methods. Yeah, the methods or the constructor defined in the superclass. Yeah, the object stays the same. It's only we access the implementation which is defined in the superclass. That would be more precise. Yeah, we access the implementation because the object, it always stays the same. Yeah, like the key point here is that, like, let's say we have the class student, but it still stays person. Yeah, so if we create student, it means that we still have a person. Yeah, at the end of the day, I mean, the person still is there. Yeah. So we cannot just remove something from person class or just we can change something. Yeah, we can change the behavior of we can change the behavior for some methods the person class has, but the object still stays the same. That's the thing. We only extend or we adjust, maybe we adjust the behavior and we extend with some additional properties, some additional behavior there. Yeah, we can extend the person class, but all the definitions, they stay the same. Yeah, so again, you still, again, first of all, to create the student, we still need to create the person. Yeah, and then simply means that you have the object student, but it has all the same properties that the class person has. Yeah, and the only thing what you can do with base is you can access. Yeah, so from the subclass, from the class student, you can access the implementations. So it means you can access the constructors of the superclass, and you can also access the implementations of the methods. Yeah, again, if you override the methods, this is what we have here. That means that this particular class will use this implementation defined here. It will not use, like if you don't override, then it will use print from the base class. But if you do override, then it will use the implementation defined here, and then you can use base to access the implementation. So implementation means the code of the, simply means the code of the method. And so that would be the implementation of the method print in the superclass, and then you can access this particular implementation from the subclass then using base. And so base, it's the simply the again, don't say the reference, but it's the way how you can, the keywords to access implementation of the superclass, because the reference still remains the same as this target object. Yeah. That's the point. Yeah. Okay, any more questions? Anyone has? Okay. Okay, if not, then we then close this inheritance presentation, and we then move to the polymorphism. So I already mentioned some key points from the polymorphism concept in the previous topic. It still is about the inheritance. So first of all, what the polymorphism is? It means that one particular object can have, actually maybe to be more precise, one particular maybe I won't really say the object, maybe element or something similar. It may have the different representations, or even maybe from programming point of view, that would be more precise if we say that one particular type has multiple different implementations, multiple different representations. Yeah, that would be maybe more precise. Yeah, so this was said is the ability of objects belonging to different types to respond to the methods of the same name, each one according to the appropriate type-specific behavior. Yeah, again, maybe easier would be if, as I just said, one particular type. It's yeah, maybe more precise. That would be the data type. It may have multiple different representations. Yeah, and that stability is an object's ability to behave differently depending on the step. So, like we have the object, and then the behavior of this object is based only on the type, how it is defined, not on the variable where is it stored. Yeah, so when we talk about polymorphism, I mentioned it multiple times before, but that's the object-oriented programming, the implementation of the. So we should distinguish the terms variable and value stored under this variable, and this also for the reference objects. The key point here is that we need to distinguish the objects, the type of the object, and the type of the variable where this object is stored, because the type of the object and the type of the variable where this object is stored, the type can be different. Yeah. So, and this is what the polymorphism is about. And so when we talk about polymorphism, then the first key point here is it is the method overloading. So it simply means that we have the virtual methods defined in the superclass, then we can extend the superclass with the subclass, and then when the superclass is extended in the subclass, then then we can overload the virtual methods there. Yeah. Simply means that, like for example, we previously had the class person and the class student. Then let's say the class person has the method maybe learn or something like that. Yeah. So for the person, there will be, let's say, particular implementation defined, and then we can, if this method is virtual, in the subclass, when we define the subclass student, then we can redefine, we can override this method learn, then it will have different implementation. Yeah. Oh, sorry, no, that's sorry, that's I just thought that we're talking about overriding. I usually mixed up their namings. Yeah, so yeah, here we have overloading, so we'll talk about overriding a little bit later. Yeah, so here we talk about overloading. I usually confuse, mix them up. Yeah, so overloading. Yeah, so I talked about overriding. This is about overloading. Overloading means that we have one particular method. Yeah, so name one particular name of the method and the returning type. So the name and the returning type should be the same, but we may have multiple methods with different parameters. Yeah, parameter pattern. Yeah, so we may have multiple methods with different parameters declared. Yeah, but the name and the returning type then should be the same. Yeah. This is permitted, but the signature of the methods cannot be unique. Yeah, so you cannot create two methods with the same returning type, the same name, and the same parameters, the same type of the parameters. Yeah. So yeah, the names of the parameters are not important, but important is the signature of the method, the sequence of the types. So for example, let's say that we have, I mean, it's not mandatory if these are the static or non-static methods, because the concept is the same. So let's say I defined two methods. So let's say that will be the methods public static. Let's say let's do something, and I have the parameters int a and b, for example. So when I do something here, so then I can define a method with the same name and the same returning type. So here is no returning type, it's void. So I say I can do the overloading. So if I have different parameter pattern, that would be correct. Yeah, so it would be correct, and that would be overloading. So it means that I simply overload this do something method. Yeah, I overload it here. But if I, then of course I cannot have the situation when the parameters are the same. Yeah, because then the signature is the same, the signature matches, and that won't be correct. And also, the signature does not depend on the name of the parameters. Yeah? So if I define something like this, it will also be incorrect here, yeah, because the signature still is the same, int and integer. Yeah, so it only checks the sequence of the parameters. Yeah, so if I say I have string here, so it means that I have string a and b, and yeah, of course I cannot have the situation when I have string here and string safe. Yeah, so string integer won't be correct, but let's see what happens if I have integer and string. then it will be correct here. So it only cares about the sequence of the parameters. And so the sequence should not be the same. Yeah. So you can have string integer string, but you cannot have string integer integer. So the sequence should not match. You can have the same types of the parameters, but please make sure that their sequence does not match. And yeah, of course, please make it meaningful. Do not provide actually the same parameters with the difference. Yeah, actually that may be more correct, but of course, such pattern and such way of writing code will not be correct if you simply overload in the way that you have, let's say, logic A when you have same parameters defined as string integer, then you want to have just different implementation for the same parameters, but just simply defined in the opposite way. Of course, this is not how it should normally be done, yeah. So don't do it. But the key point for overloading is that there may be some let's say different So the key point is you can have different parameters to be provided to the methods, which basically, once they do the same things, but they are supposed to have the same result. They're supposed to have the same purpose. Yeah, so what's the method? So we're going to calculate area, then we can let's say calculate area. We can pass calculate area. Then we can pass one edge. We can pass two edges, three edges, and so on. And based on these, based on the pattern provided, then you can calculate the corresponding area. Yeah, we can overload in the same class, also in the subclass, and the decision of each overload method's code is based on the reference type and is decided at compile time, and method overloading is also known as static polymorphism. So, for example, here we have three methods. They all have the same returning type. They all have the same name, but they have different parameters. So basically, yeah, it depends on what we provide to the methods. Yeah. So in this case, you see one of the options. What can be the reason why the overloading is used? And here we simply see that there may be additional information provided. Yeah, for example, discount or quantity. And so by default, we assume that the quantity is so for example, also maybe let's take a look on this example, because this looks quite interesting, I would say. So let's define this class. Yeah, so for this particular method, we assume that the quantity is 1 and discount is 0. For this method, we assume that the quantity is provided and the discount is still 0. And here I have the situation when all the three parameters are provided. So in theory, what can we do here? We can do the following thing. We can maybe we can call this computer sales, and let's say that we have price, and I say that the quantity is 1. So the similar way I did with the we see in the example with the constructor, same thing we can do here. We can call one method, one overloaded method from another. Yes, so and again, what simply it means, as I just said, this would be the situation when the price is provided and the quantity is 1. Yeah, and also I can say that the discount is 0. And then it means that this particular example will be triggered. Or I can say this way, then this would be triggered, quantity 1, and here, for example, I can call the method when the quantity is provided, and the discount is 0, for example. So such approach can also be used. Why not? You can call one method from another. Okay. So do you have any questions about this? Okay. Yeah, so we can use this in the way of extending, like we have here. Use default values or something similar. Let's check if the recording is still in place. No issues. No issues. It's good. Then let's proceed. So that was about the method overloading. Yeah? Overloading again means same methods, but different parameter signature. And then we have method overriding. Yes, so overriding means that we override the method defined in the superclass, and the method is overridden then by the subclass. Okay? So the method should be defined as, basically if the method is not overridden, then the default the method from the superclass is used then. Yeah, so again, this is about what I just said. All the superclasses, all the subclasses, they have this relationship SA, so they are the superclasses, objects of the superclasses as well. Yeah, and so this is the point from the methods. Methods are all inherited. They're all inherited, and then simply the idea is that all the methods from the superclass, they will present in the subclass as well, and so then we can override to create them, to create a new implementation then. And so key abilities of overriding is the ability to define deeper behavior specific to the subclasses. Yeah. Okay. So, and this is called dynamic polymorphism because of what we can see here. So here we have two classes. We have the classes sales and sales tax. So the sales tax is the subclass of the class sales. And so you can see the virtual method defined, which compute sales. Yeah, which compute sales, and here we can see how the method looks like. Okay, so simply returns the price. Then we have also the method which is not virtual, so we cannot override it from the subclass, and it has two parameters, so we use overloading here. Yeah, overloading is used here, but here we use overriding. Yeah, and then we override this virtual method, and basically where is the point? The point is here. So here we already use casting. Yeah, so it means that we use upcasting. Yeah, so we pass the reference of the subclass of the object with the type, which is the subclass of the type we cast to. Yeah, so and that means that these two variables s and st, they will all have so we can access the public methods what are defined under the class sales. So it means that from both these variables we can access these two methods. Yeah, methods compute sales and compute sales with two parameters. Yeah. So we can then access them. And basically this is what we do here. But where is the tricky point? Tricky point here is that for the variable st, yeah, so you see that we passed the object sales tags to st, but when I just simply I don't see this part, let's say that I don't see this part, yeah, this part may be hidden somewhere inside the code, yeah, so at some point maybe I can't even see, I mean that would be, I don't see it directly, that the object type of the stored under the variable st is the sales tags, yeah, so sometimes I cannot see it directly. So yeah, and then basically what happens here, I use the variable st typed as sales, and then I call the method computer sales. So if I just simply navigate to this method, what I see from to this method in the sales class, what I see this implementation. So I see that it returns the price. But actually this method is not called, yeah, despite the fact that I have the variable sales. So I define the variable st, typed as sales. I call the method computer sales from the variable typed as sales, but it does not call this method. It calls the method from the subclass, yeah, from the class sales tags. And this is basically the point of polymorphism, the key point, I would say. The method which is called, it is not based on the data type the variable has. It is based on the object type the reference of the variable is typed as. Yeah, so and the reference is typed as sales tags, but the variable is typed as sales. So, and here's the key difference. Yeah. So the type can be different than the actual object type stored there. So please be aware and don't be surprised when the logic is different, because it may be different. And when you work with different frameworks, then this may be the relevant point. And this is why, as I just explained you some minutes earlier, is when we work with the frameworks, we usually have the situation when we extend the classes provided then on the framework. And then the framework actually deals with the variables defined there. So the type of the variable is still same. But when we extend the framework, then it may use, so there may be the logic which takes the types of the subclasses instead. So this may be the point. This may be the relevant point, so don't be confused, don't be surprised when the logic is different. Okay, so do you have any questions on this? Yeah, that may be quite tricky, I would agree, but this is what the polymorphism is about. There you need to remember there is the difference between the object type, the object type and instance type and the variable type. So then there is such keyword, maybe not, I won't really say it's a really important keyword, because the purpose of this, maybe let's copy paste this code. So, oh no, I have duplicates here. Duplicates. Oh no, I don't have. Yeah, I have duplicates. Okay, so let's then replace this class Point runs of type. Oh, what's this? What's this? I'll be point to the point tolerance of that small ends. Oh, why? It's truly. What? It's truly relevant. Why it isn't? Well, it's this is the first time I see it. Let's see, so I can quickly check it. Okay. Moment, yeah. So let's try. Okay. So yeah, this is just because of them. I guess if I use M, I think this will also work then. Yeah, so it's just complaining about the type of one. Yeah, it is just complaining about the type of 1.1. Okay, so now it's better. So yeah, the operator new. So basically, what will happen if I don't use the operator new? So in fact, nothing should happen. And in fact, nothing happens. It's just it will only trigger the warning message. Yes. So the warning message it says that sales tax computer sales hides inherited member sales computer sales. That's me. Yeah. So basically, what's the point here is we have the superclass. We have the superclass and we have the method computer sales. So basically, the point here is that it does not override here. It does not override the method from the superclass. Instead, it simply creates a new method. Yes. So basically, the only difference is that we add new operator, and then we define that this is here. Then we simply define that it is not overridden method. It is a new method. So, and basically that's just a simple way how I can point. We cannot do it this way. Yeah, we cannot use override. We cannot use both operator at once. That's not possible. We can only use new or override. So for virtual methods, it's better that we use one of them. Okay, so that's just simply the way how we define, and yeah, it simply determines which methods to run based on reference type. So what does it mean? It means that so what happens here? I define both variables the same way, and then I want to call the method computer sales. So in this case, if the okay, let's run this. Let's run this and see the results. Let's see the difference. These are results. We have 100 200 and 100. So what's this one? This one, yeah. So basically, we are interested what happens here, and then what we see here, we see that despite the fact that we have sales tax object type, it calls the computer sales method from the sales class. Yeah, from the sales class. So basically what will happen if I use override instead of new, so we have result 100 as the last one. Now let's say that now I will override this. Instead of new, I override. Typo. Yeah, so now you can see that we have different results. So basically, it operator new, it simply defines what is the method to be defined in the case when we have the virtual method in the superclass. And like, yeah, so here we have the, yeah, also let's maybe a moment, where's this view? Let's go back, sales tags, yeah. So let's go back and let's define the operator new. Remember again what we have hundreds, 200, and we have 100 as the result here, and so we are interested in the last result, 100, so this will return as 100 here. It will call the method from the st, from the sales variable, but then if I change the variable type, then the result would be 110. Yeah? So basically this is the case when the variable type matters. Yeah, if we have new operator, then it is important what's the variable type. If the variable type is like if it's defined, if the variable type is the superclass, it's typed as a superclass, then if we have the method new instead of override in the subclass, then it will call the method from the superclass. If we use override, then it will call this overridden method of the subclass. Then this is the difference. Do you have the questions about it? That's the operator new. Okay. So if not, then let's move next. Yeah. So just to not mix overloading and overriding. So overloaded method means that the method is taken from the superclass. Yeah, the method. I mixed. Overloaded method means that there are different for multiple methods. For overloaded methods, there are the different sequences of the arguments there. So this is the first point, and yeah, returning type. It can actually be. It also can be different. Yeah, and so then you need to call it. The determination of which method is called is based on the parameters you provide to the method. It is defined by compiler, determined by compiler, and then the corresponding logic then to be triggered. For the overridden methods, it means that this is the method which is overridden by the subclass. The method should be defined as a superclass. The method should be defined as virtual. If the method is not defined as virtual, then it cannot be overridden. And yeah, we can use argument, we can use keyword new to then not override, but actually create a new method. Yeah, we can call it this way. So it means that in fact the method will not be overridden. It will create, let's say, the duplicate. Yeah, I would say in some case it will create duplicate, and then it will be based on the class type. I would say that may be a little bit confusing, so I'm not really a fan of the usage of new, but it is allowed, then it can be used. Okay, next one is early. Yeah, any questions about overloading and overloading? Overriding and overloading. So are these two clear for you? Okay, if they are, we move on. Then we have early binding and late binding. So early binding means translating operations or associating identifiers during compile time, and then late binding would be this is I would say mostly dynamic. It's mostly dynamically during the runtime, and yeah, it means that compiler cannot really, at the compilation point of view, such things maybe cannot really be understood. Yeah, for example, here I see the type. Yeah, I see the type of the object for S and ST. I see their types. Yeah, so this would be clear for me. But as I said, in some cases we may have the situations when these types are not quite visible for us. Yeah, they may be hidden somewhere deep inside the code, or maybe there can be some determination for them. For example, if condition A, then the type is, it can be possible that if condition A, then the type is sales, then if condition B, then the type would be sales tax. Yeah, for example, I can do it like I can say write something like input, and I can write read from console. Then if, for example, I can do this one here. Maybe here if inputs equals, let's say, sales, then I will create, oh, so if I don't, let me define sales st equals, let's say I'll start with none. Then if input sales equal, if input is sales, then I create st as sales. And then else if input equals sales tags, then I define st as sales tags. Yes, so in this case, of course, it cannot be determined, the type which will be assigned to st, it cannot be determined object type. It cannot be determined on the compilation point. Yeah. Of course, before we run this program, means that I cannot really know what will be the type of st, of the object stored under st. Right? So this is where the late binding happens, not on the compilation time point. Yeah, so for example, the usual case would be that we have the multiple classes, then the class animal, the base class, the parent class for the class snake and horse, and then we define pig as new animal, then whatever as snake, stallion as horse, then animal whatever as snake, animal stallion as horse, and so on. Yeah? So basically, the type, the keyword here is that the type of the variable is defined as the superclass, then actually the object type, the actual object type, then can be different. Yeah? So this is the point. So and this is how this will look like. So if I call the method eat, then the basically then the method from the pick class, or sorry, not from the pick class, but from the corresponding object type, what is assigned to pick variable, it's then the method defined there will be, the overridden method, it will then be called from this pick class. So from that class, what the objects from what is created then. So like in this case, this is animal class. We have it here. We're based on the class. Yeah, then we can define multiple implementations for them in multiple classes. Yeah, different implementations for them, and then based on the object type, the corresponding implementation then will be called. I can maybe define what can be accepted by the method. But for example, if the animal eats something, then I can provide what the animal will eat there, and then based on this information, we can check if it is acceptable by the animal or not. Yeah, we can define such logic. Okay, do you have any questions about polymorphism? Okay, do you have any questions? Not only about polymorphism. Okay, looks like it's too late for you, maybe. That's fine. Okay, then the plan is we have that will be it for today. We won't manage to proceed with other topics. So the plan is that we have the session on Saturday. So the session is at 6 o'clock, right? Wait, 6? No, not at 6. It's 9 o'clock in the morning. Yeah, that would be, yeah, 6 o'clock. I mean, maybe I could, but I'm not sure about if you want to start studying at 6 a.m. Saturday. So yeah, then it will be at 9, and then most likely we'll finish the theory of object-oriented programming, and then I give you then the practical tasks. Then you then do the practical tasks in class, and then we'll also check these practical tasks in class. Okay, then have a nice celebration tomorrow. So have a nice Friday, and then meet you all on Saturday.